Alright, our next example is the limit as x approaches infinity of 4x squared plus 1 over 5x squared minus 15. So again, we're taking an infinite limit of the irrational function. So first thing we're going to do is take the highest power that occurs in my denominator, which would be x squared, and divide everything in the numerator and everything in the denominator by x squared. So I'm going to multiply by 1 over x squared in my numerator, and I'm going to multiply by 1 over x squared in my denominator. I have the limit as x approaches infinity of 4x squared over x squared plus 1 over x squared over 5x squared over x squared minus 15 over x squared. Simplify. Limit as x approaches infinity. X squareds cancel out, giving me just 4 plus 1 over x squared over x squareds cancel out, leaving you just 5 plus, whoa, I keep doing that, negative 15 over x squared. If you want to go straight from this step to this step, not showing me this step, that's fine. I'm just one of those people who would totally make a mistake, and I like to write everything out, but this step is technically optional. You go straight from here to here, that's fine, but you must show this step. If you don't show this step, no credit. All right, so the limit as x approaches infinity of 4 is just 4. The limit as x approaches infinity of 1 over x squared is just 0. The limit as x approaches infinity of 5, the constant, is just 5. And the limit as x approaches infinity of negative 15 over x squared is also 0. So this leaves me with 4/5. Our next example, the limit as x approaches infinity of 4x to the third plus 1 over 5x squared minus 15. I'm going to take the highest power that occurs in my denominator, which is x squared, and I'm going to divide everything in the numerator and everything in the denominator by x squared. So I'm dividing, or multiply by 1 over x squared in both the numerator and the denominator. So I get 4x cubed over x squared plus 1 over x squared over 5x squared over x squared minus 15 over x squared. Oh, I said 0. This is infinity. Sorry, team. So 4x cubed over x squared is 4x plus 1 over x squared. This cancels out to 5. So the limit as x approaches infinity of 4x, I would just plug infinity in for x. But you're probably thinking, that's crazy. Which is going to play out in our final answer. And the limit as x approaches infinity of 1 over x squared, that's just 0. The limit as x approaches infinity of 5, so constant, is just 5. And the limit as x approaches infinity of negative 15 over x squared is 0. So you get infinity over 5, which doesn't make any sense. Like, I don't know what that is. This is the limit does not exist. The limit does not exist. So if you notice, you notice there might be a pattern that you saw. In our first example, the degree of the numerator was less than the degree of the denominator. Our limit is 0. In our second example, the degree of the numerator and the degree of the denominator were the same. So our limit ended up being the ratio of the leading coefficients. In our final example, the degree of the numerator is bigger than the degree of the denominator. So that limit does not exist. So that actually applies to every single limit. So if the degree of the numerator is less than the degree of the denominator, then the limit of the rational function is 0. If the degree of the numerator is equal to the degree of the denominator, then the limit of the rational function is just the ratio of the leading coefficients. And finally, if the degree of the numerator is greater than the degree of the denominator, then the limit of that rational function does not exist. So there's going to be some problems on tests and quizzes where it's asking you to work it out the long way, showing all your steps, aka this whole process. Then there's going to be some questions where it asks you, you can just use like the shortcut. You can just use the rules. So you don't actually have to show all the work. You can just use this list of rules to help you determine what the limit is. But know that sometimes you are going to have to show all the work. Knowing this chart, knowing these rules will help you make sure that your answer makes sense, but sometimes you're actually going to have to show all of that